Hello, I'd like to do an introduction to Chapter 15. Chapter 15 is hypothesis testing, and I'll talk about the basics of hypothesis testing. We'll get to all the details later, but I just want to give you an introduction to the main ideas here. Um, the word hypothesis in science means a guess, basically. You want to state a hypothesis about your population. And then you gather some data and you try to figure out if the hypothesis is true or false. That's the basic idea in basic science, what a hypothesis is. Um, in statistics, we do a similar idea, but it's broken down into four steps. So let's just use an example. Let's say you're doing a medical experiment and you want to know, does the medicine work? So you have some sick patients, they volunteer for some sort of trial, some clinical trial, and you give them some medicine, and one group gets medicine, one group gets placebo, and then after maybe 6 months, you bring all the subjects back into the clinic and you test them and see if they're cured or not. Something like that. So that's the basic question here that I'm going to use as an example. So does the medicine work? Does it cure the ailment, whatever the ailment is? Okay, so step one of hypothesis testing is you write your hypotheses. Now in statistics, we have two hypotheses. So I'll use plural here, hypotheses. You have what's known as the null hypothesis, which is abbreviated H with a little zero, um, which basically is it's like status quo. It's no, the medicine didn't work in this case. Usually, whatever the question is, if the answer is no, then that's going to be the null hypothesis. So the medicine didn't work, or the people who took the placebo did just as well as the people who took the real medicine. So you could say something like that the two groups are equal somehow, and usually you use an equal sign somewhere in your statement of your null hypothesis. And then you have the alternate hypothesis, which is often abbreviated HA. In our statistics book, we'll abbreviate it HA. And that is the discovery of some kind. Or it's yes, the medicine worked, or whatever the question is. If the answer is yes to it, that's almost always going to be that alternate hypothesis. So yes, the medicine works. Yes, the people who took the real medicine recovered faster or at a higher rate or whatever than compared to the placebo, for example. All right. So that's basically, in a nutshell, that's step one. Now, we'll talk more detail about how you write the hypotheses and so forth a little bit later. Okay. Step two then is you gather the data, you run the experiment, you do the surveys, you do whatever it is you're doing to get your data, and then you do some calculations. You compute, for example, X bar or standard deviation or the percentages or whatever it is that you want to gather, or whatever it is you want to calculate. So that's essentially that step two. And you can throw in a histogram or a box plot. All that stuff you learned about, you would do in earlier lessons, you would do in step two. Okay, then step three is you do the analysis. Okay, now of course we'll go into much more detail, but the basic idea of the analysis is you're asking this essential question. You're asking if the null hypothesis is true. So you ask if indeed the medicine didn't work, or the placebo group, or the people who take placebo recover just as much as people who take the real medicine or whatever it is, whatever that null hypothesis is. If the null hypothesis is true, you ask the question, what is the probability? What is the probability of getting whatever we got here in step 2? What is the probability of getting whatever we got? Getting a particular X bar or etc. Whatever it is from the data that you're looking at. All right. Now, if and that's called a p-value, by the way, the answer to that question. Now, how do you compute this probability? Well, we'll get back to that. It's related to sampling distributions, and it depends on whether you're looking at an X bar or a sample proportion, and so forth. Okay, and then step 4 is you make a conclusion. It's decision time. Let's draw a line here. All right, so let's suppose that the p-value is really low. Let's say that you do the analysis and you make a statement. If the null is true, there was only a 1% chance of getting this particular X bar that we got, let's say. And so then you would say, I don't think that null is actually true anymore. And so basically, if the p-value is low, then you'd say the phrase is, then you reject the null hypothesis. So it's just the way people talk in statistics. They don't say, I think the alternate's true. People say, I reject the null, which implies then that you think the alternate is true. All right. On the other hand, if the p-value is high, now how high is high enough, how low is low enough, we'll talk about that later. But this is all just very general here. If the p-value is high, so if you say if the null hypothesis is true, if the medicine it really isn't effective, for example, there's a 40% chance of getting the results we got, for example. Then you would say, well, I'm not going to reject that null hypothesis. And so if the p-value is high, then you say, I fail to reject the null hypothesis. Which essentially means that there's no evidence that the alternate hypothesis is true. So no evidence for that null hypothesis is essentially what's going on there. And that's in a nutshell. That's the 4 steps. Now we'll in future lessons we'll talk more about how you write these hypotheses. The gathering data stage you already know about. We don't need to spend too much more time on that. We'll talk a whole lot about the analysis stage here, what exactly p-value means, how you calculate it, and how you look at your sampling distributions and use them to compute p-values and so forth. And then the conclusion, and what does the conclusion mean, and how do you come up with the conclusion, how high is high enough, how low is low enough, and all that. But that's a basic introduction to hypothesis testing.